All right. So, 12A looks like this. Okay, what's the first thing we always do whenever we encounter a limit where the x value is approaching a number? Plug in the number. Very good. If I plug in 5, I get root 5 minus root 5, which is 0, and then on the bottom I get 5 minus 5. Okay, now, so do we know the answer right away? No. This is indeterminate. This just tells me that I got to do more stuff. We got to dig deeper here. So I'm going to show you a trick here. You might have seen it before, possibly. And it involves this very famous identity. What do you get, guys, if you go A plus B times A minus B? What does that? This one's really famous. It's the difference of squares, right? It would be A squared minus B squared.
Equals C squared.
No. Okay, this is a really commonly used identity. It's one that, it comes up a lot in mathematics. It's one that you make sure you understand this one, okay? Now, just a quick little refresher. Where does this come from? It's not magic. It's if you just multiply this out, A times A squared. A times negative B, negative AB. B times A, and then B times negative B. What happens to these two terms in the middle? They cancel right out. So that's where it comes from. It's nothing crazy. It's not like some crazy guy with a beard and hair like that came up with in his ivory tower. It's just simple multiplication. Okay, so but it just happens to be a very famous result when it's these two numbers are the same, and in the first one it's a plus, and the second one it's a minus. Okay, or vice versa. So the trick here, with that being said, do you guys think we can do something? I don't really want these square roots to be here. So what if I multiplied this by root x plus root 5? So think about that first. What would that achieve? Well, first of all, is that okay just the way I have it? Is that okay just to multiply the top of my fraction by something? As long as I also multiply the bottom by the same thing. So what is this number in red here? What is this number? 1. So that's what we do. By the way, guys, when you're doing algebra, a lot of the time what you're doing is really analogous to simple stuff you did back in elementary school or middle school, like, oh, the fraction 2/3. Could I multiply the top by 4 and the bottom by 4 and write that as 8/12? Is that okay to do that? Yeah, of course, because you just multiplied your fraction by 1, so that's okay. So that's all we're doing here. We're multiplying our fraction by 1 in a really sneaky way that's going to do something. Okay, so let's go. This equals the limit as x approaches 5. All right. What do you think we're going to get when we multiply this by this? Top times top. Very good. X minus 5. Let's ask ourselves, do we understand that? Mm-hmm. Do we understand why what we just did was basically just using this famous identity?
Yes.
Okay. Good. The bottom, I'm going to be a little bit sneaky here. Do you guys think I'm going to go this times this, this times this, this times this, like do the whole foiling thing? Mm-hmm. Or do you think we should just leave it like x minus 5 times this, because now the top is kind of like 1 times x minus 5, and the bottom is this weird thing times x minus 5. And so I can divide the top and bottom out. Basically, I divided the top and bottom by x minus 5. And look what I've got. I've got the limit, as x approaches 5, of 1 over root x plus root 5. All right, what do I do next? Am I done?
No.
Not almost done, but
Gotta plug in 5.
plug in the 5. 1 over root 5 plus root 5. I can invoke the famous banana theorem here. 1 banana plus 1 banana make 2 banana. Alright. What is that? It's a number. It's the limit, yeah, it's a number, so we found the limit, that's the answer. Yay!
What?
Great.
Isn't there like a genre of TikToks that are like oddly satisfying?
Yes.
What AJ just did was
Yeah.
the opposite of that. He proceeds to draw these lines in here.
Oh,
Oh, AJ, how could you?
It's so great. Don't worry about it.
Is the kid look?
Yeah. They're so close to the letters. Hey,
That's
God, it's
the
not even like close to halfway down the middle.
Yeah.
that's something I would do.
God. How could you do this to me, AJ? Do you care about my feelies? Alright, let's do another one. One more example. Before we move on, before I erase this, are there any questions on any of those steps? Anything about this? Okay. What do you guys think is the next one we're going to do? It's on this page.
B.
No. B is like the same exact thing. D is a little bit weird though, right?
That's in chat.
What?
That's in chat, so it has to be that.
Oh, F, the most respectful letter there is. No, we're gonna do D because D is like kind of weird, right? Would you guys agree with me that B and C are like, okay, B and C are pretty much the exact same.
Yeah.
Not much difference there. But D is kind of weird. The top only has 1 square root in it. And there's more than one symbol under the square root. That also makes things a little bit more weird. So, 12D. D as in daffodil. Daffodil. The limit as x approaches 3 of square root of x plus 1 minus 2 over x minus 3. What's the first thing we do?
Plug in 3.
Plug in 3. Let's see. Plug in 3, we get 3 plus 1 makes 4, whose square root is 2. 2 minus 2 is 0.
That's no good.
Bottom is 0 as well. Oh, it is good. That means it's going to be a more interesting question. Okay. What?
I don't want to do any algebra.
True, yeah. Just give up here. Just guess.
Done. This is no longer game.
Can someone guess the answer? I wonder.
7.
7, good guess. Good guess. Anyone else?
1.
1, good. 1's, 1/3. Good guess.
1.
1.
That doesn't have
1/3's actually pretty close to the answer.
2/3.
1 over.
Let's do it.
Wait.
Who thinks they know what the conjugate of that numerator is?
X plus 3.
So x plus 3 would, in some sense, be the conjugate of this, but the problem is, if I multiply by x plus 3 over x plus 3, I'm still going to have this troublesome square root. My goal really is to get rid of this square root. So, anyone else have an idea of what the conjugate is going to be? The square root of x plus 1 plus 2. Notice that this is the exact same as that. a lot of people want to go, understandably, they want to go square root of x minus 1, something like that. But the problem with that is I need it to be that this, oh, I shouldn't have erased it. Sorry. I really want to use this fact. I want to use the fact that a plus b times a minus b will give me a squared minus b. So the goal is to make sure that these two things are exactly the same. It's the same like a, so that the a squared won't have a radical in it. Won't have that square root symbol. So that's where the minus changes into a plus, is between the two terms. So you can see that's kind of a tricky thing to make good sense of, right? I mean, you gotta. So just to recap, you gotta think of like this is your a, this is your b. So a minus b times a plus b. That's the idea. All right. So what's the bottom of my fraction gotta be? Plus 1 plus 2. Very good. All right. Time for a little bit of careful calculation. All right. The top is going to be a minus b times a plus b is going to be a squared minus b squared. So what's a squared?
Plus 1.
Plus 1 minus 4. Any questions on that? No? Someone in the other class pointed out rightfully that isn't it the absolute value of x plus 1? Which is correct, because the square root of x plus 1, well, it is and it isn't. I mean, I don't want to confound anyone here, but the fact that x is approaching 3 is the key. So if x is approaching 3, then I know that this term here is going to be positive, so I don't need to worry about like absolute values or positive, negative. Does that make sense? So if you were wondering about that whole thing, like, oh, you're squaring a square root, is that, you know, although to be really accurate here, the square root of a thing squared is actually equal to that thing, but it forces it to be not negative. But anyway, we'll get into this detail later on in this class, because x can't be negative if you're square rooting. Okay, moving on. So for our purpose, long story short, for our purposes here, if you're squaring a square root, you can just say it's the thing under the square root. All right, on bottom, what should I do? Multiply them, but keep them separate. Like this. Are we all okay with that? Make sense? So what's going to happen?
It's now x minus 3.
Yeah, the top, that right there is x minus 3 times 1. Okay, x minus 3 cancels out the x minus 3 on bottom, and I'm left over with is 1 over this. So what do we do now?
Plug in the 3.
Plug it in. So what happens if we plug in?
It's 1/4.
So Hannah Banana was pretty close to her guess. She guessed 1/3 at the beginning of this. Everyone's cool with how I'm getting the 1/4, right? Yeah. All right, so that's all there is to it. It's kind of weird, but this technique shows up in when you study calculus. And it's just kind of an interesting, the idea of a conjugate shows up not just in calculus, but a whole bunch of stuff where you're trying to simplify an expression and you're trying to find something maybe to cancel out to write it simpler. So there you go. You got 12 questions, or we just did 2, so you got 10 left to do on your own. You can stop this